Kingsley Haynes, I'm the chair. I'm not sure exactly what I'm supposed to do, but I'll at least introduce people. We'll start off with Peter Beatty, who's going to talk a little bit about welcoming us. So Peter, it's turned over to you.
Okay, thank you, Kingsley, and hello to everybody. It's good morning if that's what you'd like to hear, but also good evening if that suits you better. And a very warm welcome to this virtual conference of the Regional Science Academy. It's good to be back again, and 2020 for most of us is a year we'd sooner forget. But we've got resolutions in 2021 to get the show back on the road. And this session in Palm Springs, if that's where you think you are, is going to be the first of many, we hope, in 2021. Our program today splits into two parts, post-corona mobility being the first, and the second being great minds in regional science. So I'd first of all like to thank J1 for his collaboration in terms of getting this session going. That's very helpful to all of us. And I'd like to thank you all for coming along to this session. Strange though it may be, my experience of the one we had at NUSC was that it was actually pretty successful and certainly a lot better than not having these sessions. We're doing it under some difficulties, but we're coming through it very well indeed. So thank you for all of those who's agreed to speak. I just mentioned that the Academy conference sessions are important, but there's more to the Academy than conference sessions, virtual or otherwise. And I'd just like to place on record the excellent progress that we're making on the publications front. Within the footprints of Regional Science Framework, we've published the first of our volumes on Great Minds in Regional Science. We're working hard on the second, that's Dave Plain and myself. But we've also published the first book in the Voice of Regional Science series on the economic geography of cross-border migration. So watch this space in terms of more publications from the Academy. So I'd like just to close these very brief remarks by paying tribute to Karima, who brings tireless energy to organizing such activities, as well as thinking up very excellent themes for the Academy's program. So without further ado, I hand back to Kingsley, who's going to steer us through the program this morning or this evening or whenever you think it is. Thank you.
Okay, just welcome everybody as well. This is the first half of the session, and it's on the post-corona mobility. I'm going to turn it over to Danny, who's going to, and his co-author, the other Danny, and COVID-19 as a natural experiment in mobility research. So Danny, I'm going to turn it over to you.
Kingsley, thank you. And I will start by telling you all that the original motivation for the paper that I sent to Dave Plain was indeed questions concerning the impact of this COVID experience that we all shared on how cities might evolve spatially and how it might affect mobility. And indeed, we carried the thoughts further and asked ourselves whether it will affect greenhouse gas emissions and the warming of our Earth. However, we will present today only the first part of our string of papers, and we will concentrate on how the spatial evolution of cities is affected by COVID, and the prism is changes in land values. So let me start by saying that we think that we understand pretty much how systems of cities evolve, how different cities in the system grow or do not grow. And we generally use endogenous growth models to understand these evolutions. What we do not understand very well is how the geographic direction of the growth of individual cities evolves. So in which direction, spatially, do cities grow? So the motivation of this paper is to try to understand the spatial evolution of cities, and the paper is titled, as you can see on the bottom of this screen. It includes, well, I guess I can say my intellectual grandson, Erez Buddha, who is a PhD student of Danny Breutman, who was my PhD student. I, in the beginning, used the term natural experiment to describe what has transpired in 2020 until now. And then I saw this paper, it's an occasional paper published by Utrecht, that called this pandemic a forced experiment. It was forced on us. And the question then is, if the impact of this experiment will continue and will have some long-lasting effects, how will it affect the spatial structure of cities? There are a variety of studies that speculate about what percentage of the workforce in different cities can, in fact, continue to work from home and therefore affect the demand for, let's say, office space, for shopping facilities, and so forth. One of these speculations is by the OECD, which claims that Greater London has the capacity of more than 50% of its workforce to work from home, and Washington, D.C., and well, in Washington, D.C., almost 50%. So we developed a simulation model, and we calibrated this model with georeference data of the Tel Aviv metropolitan area. So you can see here on the left, Israel, and we took this rectangle marked in black, which is here on the right. It includes all kinds of cities, from the northern part to the southern part of the metropolitan area. The engine that moves this model forward are the choices that land developers make concerning the land parcels that they decide to develop. Of course, there are restrictions of land use plans and so forth. But we want to model the developers' choices. And we simulate this search process of developers by looking at all parcels of land in this rectangle I showed you before, and we try to identify those parcels that can be improved by converting them to the best and highest possible use. So we look at all the parcels, and we use we use historical land values, we use recent land values, we use the actual urban structure, we use land use plans, and with the help of all these data, we do some spatial analysis and identify future development hotspots. So the data is actually quite vast. We have the footprints of buildings, we have heights of buildings, we have existing land uses, we have land use plans for all this area at a very detailed resolution. And then we have historic transaction data, all the sales of properties that took place from 1998 to 2020. And this is great because this allows us to calculate the land values. So land values, very simple calculation. Developers sometimes call these type of calculations combination deals. One side brings the land, the other side brings money, and with these two datums, we can calculate what is the land value, which is the price of an apartment per meter, for example, and the size of the apartment. So this is the value of the apartment per meter, less the construction cost of this 1 meter. This gives us the land value. So we have the statutory plans. So in this picture, it's not very detailed, but you can clearly see that there is a lot of area which is not built. This is the green stuff everywhere. It also exists inside. Many, many years ago, we actually calculated the fractal dimension of the built area in Tel Aviv city. And then we found that there is a lot, about more than 30% of the land mass of Tel Aviv city is not taken up by the footprints of buildings. So we have here the statutory land use plans. They restrict where we can build. And then we calculate the built density, which we normalize, yes, by means of the kernel density with a certain bandwidth and for squares, cells that we selected of 50 meters. And you can see here on the right that the density, normalized density, highest being 100, is quite different in various places in the metropolitan area. Now, in the first period, and we divided the history of this area into the pre-2015 period, the land values are already embedded in the existing built area, and they explain more than 50%, 55% of the variation in building density. And we calculated that each additional 1% of land value is associated with an increase of less than 1% in density during this period. This reflects a certain inertia in the development of the Tel Aviv metropolitan area and the very low standards of density, even though most of the population of the state of Israel resides in this area, the average density in the metropolitan areas, excluding the green spaces, is 8 apartment units per dunam. Dunam is quarter acre. I think I'm right. So very low density. After 2015, the spatial evolution of cities changed and the average density began to rise, and that's why we see different color intensity throughout the region. We then calculated, by means of a regression, the probability of an increase in land value during this second period. So I don't have to explain this equation. The D's here, the dummy variables, are plans, build density, and land value density. And they either receive 0 or 1 depending on these specifications. The results of the regression gives us an indication of the probability. So I took this, we took this coefficients and calculated land value increase probability here on the right. And you can see that depending on the values of the various variables in the metropolitan area, we have different probability of an increase in the value of land. And this increase in the value of land is a critical variable that, with the help of which we can decide where developers will choose to buy land, convert land, and build more intensively. So we have here build density, and you can see here the colors. So that the darker the area, the darker the gray, actually even reaching black, the built density is high, and we mark with red, and we can see it here in various places, where land density is about more than 50, and the land value density is more than 50, and build density is 75. These are the areas that we claim developers will take a look at. And when we reduce the land value density to 40, so there are more spaces, red spaces, where developers might choose to build. We change it even further, and you can see that much greater areas developers may choose to build, meaning that because there are built areas there, that there are low density housing there. They will buy the buildings, take them down, and build something more intensive. So we added here in blue, poor choice of color, we should have used green, open areas, areas that are not built. And we can see that in this town, in the middle, there is open area that would be a prime candidate for developers to build. Here, in various places, we see open areas that developers will build. Not only there, but there in particular. So what about this pandemic? If we assume that new work and shopping behavior patterns will continue after the end of the pandemic, so we simulate what if scenarios. What will happen if? we claim that people will avoid crowded spaces and the demand for high-rise office and housing buildings will decline. So assuming that suitable places for future urban development need to have a build density less than 75 on this normalized scale, we further reduce the preferences and test a scenario with maximum suitable build density of 50. So here we see it, okay? So now it looks a little bit different. Areas with land value density that's greater than 25 and build density less than 50. So this is a COVID scenario. And you can see that as here, the quantity of land that is destined to be developed is lower. So if we want the same amount of land to be available for development, so we did another simulation, we reduced the land value density to 22, and you can see that more spaces are available for building. And here we have also the open spaces. So the results suggest that several areas that were previously considered suitable are not considered suitable anymore, and therefore the red spots appear more dispersed and pierced. And as a consequence, the total suitable area is reduced. Under the post-COVID-19 scenario, the areas prone to future development pressure are more dispersed and overlap more frequently with planned open spaces. And of course, we do need to continue to study this thing. And this is speculation. We truly do not know how people will react. I think from my personal experience with developers, some of you know that my consulting firm is now 35 years old, and that I work mostly with developers. This reflects their thinking. But what we don't know is how the demand for housing, for office space, will in fact materialize. So I thank you, and I'm looking forward to hearing Dave's comments and then others. So I'm stopping the sharing.
Thank you, Danny. We're doing very well. David, I think you're up now for the discussion. Please go ahead.
Great. Well, I found this really a stimulating paper. These days, it seems to me a lot of what we're doing in regional science is sort of little tweaks to things where the questions are already well established. This one paper reminded me of sort of the glory days of regional science back in the 50s, 60s, 70s, and 80s, where we were sort of looking at phenomena afresh and then bringing in available techniques and data resources and so on to try to do good things. In 2020, 2021, we've got a lot more available computer power. Israel has some incredible data here for doing this kind of micro simulation model. And I just found the whole project quite stimulating. And then to think about impacts on development patterns of COVID in this fashion just seems really interesting to me. I have one main comment and a couple of questions for Danny. My first comment is that the end game, as he presented it to us, and this is still very early in the team's work, as I understand it, is presented as being projections. And it seems to me that doing projections about the impacts of COVID is really hazardous. Whenever we have a system shock of something major like this, projections are just, extrapolating past trends is really what projections come down to. just isn't all that relevant. What I think you have here is just this wonderful monitoring system to actually see, as events unfold in the next few years, you know, what the changed behavior of the individual demand of the developers and of Israeli planners is going to be. So I would just, this may just be a semantic thing, because in a sense, what you're doing, your projections really are just extrapolations with different assumptions about different density levels that would open up different amounts of land. But it'll be really fascinating to see how things play out as we move forward. So that's my general comment. My two questions, you present this very nicely as development patterns being this dialectic between developers and planners. And you mentioned that you yourself, with your long history of working with developers, I think you have a wonderful handle on what Israeli developers are thinking. But what about the planners? What is a planner to think about right now in terms of how the context is really changing in a post-COVID world, or a continuing COVID world, which is maybe what we're going to be dealing with? I think we have a lot. I think all of us have some sense of what, you know, people are thinking about, but what are they really going to do, and what's a planner to do, you know, to get out ahead perhaps of some of these trends, or can they sit back and watch things? Developers are often kind of reactive. Planners are even perhaps even more so, but what the planners do really, you know, kind of set the parameters for what developers can do. So I'd like some further thoughts from you about the role of planners. And then finally, this model you've developed, the financial measure, you know, comes out of real estate practice, but it's an interesting one. It's not one we've seen in a lot of traditional regional science research, and the whole simulation model itself is rather novel, as I mentioned. I'm just wondering how generalizable this is. Could this be applied to, say, a European development context, or a North American one? I mean, the underlying conditions are really different. The underlying densities, the history, the developable land available, and the whole institutional structures of the development communities versus planner communities are quite different. So I'm just wondering if you could pontificate a little bit about generalizability of this to other contexts. So thank you very much, Danny. I really enjoyed having
Thank you, David. Danny, do you want to take this?
Yeah.
Then we'll take some questions afterwards. So please go ahead.
Yeah. So let me first say something about the first question. And I'll address it in two fashions. One, for 10 years, I was the representative of the Technion at the National Planning Board. So in Israel, we have local planning boards, metropolitan regional planning boards, and then we have a national plan. And I left, not because my term was over, but because I was totally disappointed in the frivolous and non-systematic fashion that the National Planning Board dealt with variances. So sometimes it approved them, sometimes it didn't approve them. And then a friend of ours, of our authors of our paper, he sometimes participates in the regional science meetings, Benenson from Tel Aviv University, and his team wrote a paper some 20 years ago. They took a regional plan of their areas, of the area. Somebody is being called. They took the area surrounding the Tel Aviv city some 10 years, I think, after the plan was approved. And the plan becomes a law. It's a law in Israel. And then they compared the reality with the plan. And the upshot was that most of the building, the quantity of building was forecast properly by the planners. But the location of where building was taking place was mostly contradictory to the plans. And I would say that the problem is that plans pay very scant attention to economic processes. In other words, they do not take into account where the demand is, where profitable building might take place, and therefore it's a constant struggle between objectives that have nothing to do with economics and economic forces. Now, you ask also whether this kind of modeling can be appropriate for other places. Well, I must be quite humble. I'm not sure, even though I lived quite a few years in the States and even taught in a planning department for 10 years. I'm not sure that I am ready to speculate to what extent variances, and this is the main planning tool here, variances are implementable so that irrespective of what the land use plan is, developers' interest in highest and best use as they see it and in profitability of their projects can be in fact implemented. In Europe, I'm unfamiliar with it. And maybe our European friends will be able to say something about that.
Thank you, Danny. Let's open it up for questions in general across this. Anybody want to? Do we have any questions that are open? Not sure if we want to do the system of raising hands or not. There we are. I think you've got it in the bottom of your screen to raise hands if you feel like it. Okay. Okay, Marina.
Yeah, hi. I had a question. Given the assumption of your model of more dispersed future development, and that means less concentrated competition for land, if we think bid rent kind of, but the land is limited, especially close to employment in central areas. So what's going to happen to prices in urban cores, you think?
Well, first of all, the demand for living and working outside the core, urban core, has to do with not working in an office building, working at home. Incidentally, there was a very interesting paper by, I don't remember the second author, but Jacques Thies and a colleague just published a theoretical paper, NBER, that that speculates whether or not this demand for working outside of offices may not mean that we in fact will be building more and not less, however, in different locations, including logistic facilities, yes? So we speculate, we don't know what will happen, but it certainly seems to us that if people want to not work in major cities, then rental rates will drop. In Tel Aviv, rental rates already dropped by 30%. And the question then, what will we do with the high-rise buildings? Will we convert them into housing? Well, our feeling is that people don't want to live in high-rise building. I live in a high-rise building in Haifa, and there are issues, you know. People don't go in the elevator together with their neighbors. So I go alone, and I have to wait forever, and all kinds of problems. They don't activate air conditioning in the elevators, all kinds of problems. So I'm not sure what will be with these high-rise buildings in the heart of Tel Aviv that are increasingly abundant. So I'm not sure what will be.
Danny, thank you. I appreciate that. I think it's been a delightful piece. I think we need to thank you for the efforts. And I think we need to continue to move along for our thing here. The next paper is called Understanding Mobility Change in Response to COVID-19, a Los Angeles case study. And Yung Lu from USC, and also Jen Gilano, also from USC, will present the paper. I will, about 5 minutes or so before the end of your thing, I'll stick my hand up with a 5, and I turn it over to the two of you.
Thank you. Thank you very much. Yugang, do you want to share the screen? This is a very different paper than the one that you just heard. We are looking at what is actually happening as a result of COVID-19 in terms of mobility changes. In California, we've had many different periods or rules, policies being put in place. So it actually gives us some great information in terms of how people respond, not only to the threat as they perceive it, but also to government rules and regulations. We were very interested in particular in looking at how travel behavior responses vary across socioeconomic groups. And so much of this, most of this presentation is about the similarities and differences across different socioeconomic groups. Before I get started, I just would like to share an anecdote with you with regard to the previous paper, and that is that the big news here in California is that apartment rental rates in San Francisco have dropped further than rental rates in Oakland, which is its much less visible neighbor across the bay. And rents in San Francisco have dropped by about 30%. And the estimate, and one of the explanations is that about 50% of the workforce in San Francisco, of course, is in the tech sector, and they all can work from home. And they've all decided to leave, or many of them have decided to leave San Francisco and go to other places to work from home. So, Danny, your story is international, and it'll be interesting to see how it goes. Okay, next slide. All right, so we all know, I think, all of this. It's hard to keep track of the actual data because it changes so fast, but we're at about 110 million cases and 2.4 million deaths globally. The United States has had a particularly hard time with about 25% of all the cases in the world and 20% of deaths. We are moving at least now more slowly to half a million deaths in the US. As you all know, we've all been told that the only thing we can do at this point is non-pharmaceutical interventions, meaning social distancing and face mask wearing and so on. There have been all sorts of business closures, different policies around the world. and different variants of shelter-in-place orders and lockdowns. So California has been no different, and LA in particular has been no different, with essentially these varying policy decisions as the pandemic has proceeded. What we do know, at least in Southern California, is that there is higher risk for disadvantaged populations. In Los Angeles County, about 75%, 3/4 of all the COVID cases are coming from the poorest neighborhoods. It's important to note that COVID arrived in the richest neighborhoods, as you would expect, because those are the people who were most internationally mobile. But it rapidly moved into low-income areas and has had much more of an impact there. So we've got about 60% of all COVID cases among Hispanics and only 12% for white, which is disproportionate to their shares in the population. Next. So we had basically two research questions. One is how does COVID affect people's travel behavior? And secondarily, the different population groups respond differently. And as I mentioned before, socioeconomic groups in particular. Next slide. So this is the maze-like diagram to kind of tell you what's happened and what we are studying here. So we start out on January 1st of 2020. And so our first stage is before the pandemic ever happened. And then on March the 19th, California issued its shelter-in-place order. So our first stage in our analysis is while that shelter-in-place order is in effect, and that goes until May 8th. On May 8th, the county started reopening. And this was when there was kind of a perceived decline in cases, and it was thought that this was when we could start to safely reopen. So that stage went on until July, until cases ramped right back up. And then there was this sort of modified shelter in place that applied to some activities, but not all. So we call that business restriction, and that goes on until August or so, or the end of our data in early August. Next. So the data is from something called SafeGraph, a company called SafeGraph. And I really want to make a pitch for this company because unlike other companies that deal with GPS-based data from cell phones and will only sell it to you at very high prices, SafeGraph actually made its data available to any researcher who had an idea about doing research on COVID. So this is basically an open source data set that anybody can have access to. And it really generated a huge amount of data as a result. I'm sorry, a huge amount of research as a result. So what it does is measure foot traffic patterns to various points of interest, as they are called. And it's based on the GPS locations from when you use an app on your phone. There are about 850,000 devices in the data set for LA County, which is about 8.5% of the population. So it's actually, you know, a much better sample than you'd ever get, for example, with a travel survey. It's anonymous and it's aggregated at the census block group level. Next slide. Okay, after this slide, I'm going to turn it over to Yu Gang, who, by the way, is a PhD student. He's working on his dissertation as we speak. And he, of course, did all the hard work here. So we had the demographic data from the American Community Survey. We also got data on people's access to internet and computers. We also put together weather data to control for bad weather. And we also kept a track of COVID cases, and that was through the LA Times. So next slide. Okay, and I'm going to turn it over to you, Gang.
Thanks, Professor Giuliano. Yeah, so as Professor Giuliano has mentioned before, we just want to study how different population groups respond to COVID. So we, in this study, we just divide all the population in LA County to various population group, depending on their income level and also their ethnicities. So we just divide, based on the income level, we just divide the population group to high, middle, and low income levels, based on the quartile of the median household incomes of each CBG, census block groups. And we also divide the population groups to white, Hispanic, African Americans, and other races based on the proportions of each race in each census block groups. So finally, we totally have 12 population groups from low-income Hispanics to high-income white. And then the map in the right just shows the spatial distributions of each population groups. We can see for the high income and white people, most of them just live in the outskirts of the counties. And for the low income and the Hispanic and the African Americans, most of them live in the urban core and in the south central Los Angeles. So then we use a difference in different regression models to evaluate the impact of various policies on mobility change among the different population groups during the pandemic. The idea is to compare the changes in mobilities across the 4 different time periods we just show, and among the 12 population groups. So the base time period we use is the period before the pandemic, which is from January 2020 to mid-March, before the shelter-in-place order enforcement. And we use the base population group as the low-income white to compare how different population group responds to the COVID-19 policies. And we also use 2 mobility measurements to estimate the mobility trends during the pandemic. One is the census block group visits per device per day, and the other is the number and the proportion of devices that remain at home for 24 hours, which means the proportion of devices stay at home for the entire days. So this slide just shows the spatial mobility changes in 3 different times: pre-pandemic, shelter-in-place phase, and the business reopening. So we can see before the pandemics, we can see, in the maps, each yellow line means the travel communications between 2 locations. So we can see before the pandemic, there are the most travels in Los Angeles counties and the nearby areas. And when it's turned to the shelter-in-place phase, we see less travels in this study areas. And when we went to the business reopening phase, we can see more travels than the shelter-in-place phase, but never the travel level never come back to the pre-pandemics. So we can see a decreased travel pattern decrease in shelter-in-place, then a little bit increase when the business began to reopen. So this slide shows how mobility changes across time by income levels. As we mentioned before, we have 3 income groups in our study: high income, middle income, and low income groups. And we use 2 mobility indicators to reflect the mobility levels, number of sensor block visits, and also the proportion of device at home. So for number of sensor block visits, we can see a dramatical drop of mobilities near the shelter-in-place order issue days, which is in mid-March. And the decrease of mobility lasts to mid-April. After that, we can observe a gradual rise in mobility, and then the increased trend level just decrease in the early June. And when the closure was reinstituted due to the second resurgence of the COVID, we've seen just the increased pattern become consistent. And for the proportion of device at home, we can also see a dramatic increase when the shelter-in-place order issued. And for the different income level groups, we can see before the pandemic, high income is rather to go out more. But after the shelter-in-place order issued, we can see high income travel most, and the low income travel less is travel less than the low income is travel more in the stage 1, which is shelter-in-place phase, than the high income people group. And also for the stay at home, we can see after the shelter-in-place issued, we see high income stay at home most, and the low income stay home less. So we also did the analysis for the different race groups, and we assume the different race may also respond different to the pandemic. So similar to what we see in last slides, we see a drop for the number of sensor group visits when the shelter-in-place issued. And it shows the Hispanics, which is in the red color, are more likely to travel during the pandemic, while the white people, which is in the black color, green color, travel much less than Hispanic and African Americans. So some findings from our general mobility analysis. So in general, we think shelter-in-place order is very effective at reducing people's mobility. People with different income level also respond differently to COVID-19, and also the different races also have different response to COVID-19 too. So when we look at the response to government orders, we see in the shelter-in-place phase, the mobility is reduced by 41%, and then the stay-at-home increased by 63%. And when the business began to reopen, we see the mobility increase a little bit to 8%, and then the stay-at-home proportion down to 12%. And after that, we can hardly see, we just see a steady increase in mobilities. And in the second period of restriction, business restriction, we can hardly see any changes, which means the second period of restriction has no effect on the travel behavior of population. And when we look at the different income levels response to the COVID, we see in the shelter-in-place phase, the high income decrease the travel most than the low income. And when the business began to reopen, we can see high income increase travel more, and the low income increase travel less, which is the reverse pattern when compared to the shelter-in-place phase. And when we look at different races response, we see the white is more responsive to the shelter-in-place orders than minority populations. And when the business reopens, we also see white people are more responsive to the minorities. And one very interesting findings we found is we found that COVID-19 cases has very few impact after the early period, which means COVID-19 cases only effective in the shelter-in-place order phase, but not have too much effect after that. So the previous slide just shows the analysis of general mobility change during the pandemic. So the finding shows the low income and the minority travel more than high income and white during the pandemic. So we are curious if various mobility patterns of different population groups are consistent for all trips, or different. They have different response for different trip purpose. So are low income and minority people go out more often for work trips, or they just go often traveling more for the shopping or recreational activities? So to answer these questions, we just divide all trips to 5 categories based on the trip purpose. So including 4 discretionary trips like shopping, family, personal business, social recreational activities, and medical dental trips, and 1 non-discretionary trips, the work trips. So here we show an example for mobility trips for different trip purpose. For example, so here we show the travel mobility changes for work trips and the social recreational activities. And it seems for both trips, the low and the middle income groups and Hispanics need to go to work more than other races, and the similar patterns are also found in the social recreational trips. So when we look at the map here, the blue lines means the Hispanic. We see the Hispanic always has a higher travel mobility than other races. And also for the social recreational, we always see the Hispanic has the most travel mobilities during the pandemic. So based on that, we also have some findings for the mobilities for different trip purpose. So for in the shelter-in-place phases, we see a lot of jobs for the social and the recreational and the shopping trips. So the social recreational trips reduced by 110%, and the shopping trips reduced by 94%. And then the work trips also reduced a lot by 100%. And when the business began to reopen, we see the social recreational activity trips and the shopping trips increased by 30% and 8%, which would contribute to some business began to reopen. And then the work trips continue to reduce by 7%. When the business, a few business began to close again, we've seen the social recreational trips and the shopping trips reduced by 12% and 18%. But at this stage, the work trips is increasing by 9% when compared to the last period. And we also see in the shelter-in-place phase, high income decrease the travel more for both work and discretionary trips, and the low income decrease in travel less than the high income group. And then when the business began to reopen, the low income increased travel less for work trips than the middle and high income. And we found high income groups increased travel more for the discretionary trips, and the low income increased such trips less. And a very similar trend has found in the business restriction phase. And for different races, what we found the white and the other races are more responsive to the shelter-in-place order, and the Hispanic and African American is less responsive to the shelter-in-place order. And in the business reopening phase, Hispanic and African American increased travel more for the work trips, and white and other races are more responsive to the discretionary trips. And Hispanic and African are less responsive to the discretionary trips. And a very similar trend also found in the business restriction phase. So we come to our conclusions. The first, we found in the shelter-in-place.
We're running over, so please try to wrap it
Oh,
up.
I'm sorry, I didn't see your hand.
Yeah. Sorry, at least it's in the last slides. Yeah. So we found the shelter-in-place order was very effective in reducing travels, and the low-income and the ethnic minority groups were more likely to leave home during the pandemic, both for work trips and discretionary trips. So we assume this is because the low-income and the minority population are has less ability to work from home. So they may lack access to internet and digital resources. And most of low income and minority work at essential business like grocery stores, or business require in-person service like restaurants. And also for this low income and minority population, they has less capacity to purchase service like delivery and in-home child care. So we think the policymakers should.
Thank you.
Yeah, thank you.
We're
Sorry.
done.
I'd like to go to Peter now and ask him to comment on the paper. Peter Rogerson, please.
Sure, thank you very much. And I'd like to just start by saying I really appreciated receiving a full, complete manuscript in a timely manner. It gave me a lot of time to look at it and think about it. And for those of you who have just heard this talk, I mean, it was a very good, complete talk, I thought, but also the paper, you should know, is really very well done and very, very complete as well. I've got just questions and comments in 2 or 3 quick categories here. One is just, I'd like to hear a little bit more about the data set and the data source. I mean, it was introduced in the beginning, and it does seem like just a tremendous resource for researchers to look at questions like this. And I wondered specifically if it was only available for a certain amount of time or for certain topics, or you had to apply, or can anyone apply at any time, and you know, what is the cost and so on. So that's one quick category there, that hearing more about the data. The results I thought were very interesting as well. I mean, you know, the sharp downturn upon the stay-at-home orders was very striking. You know, just as interesting, I thought, was this sort of steady change after the opening, and how those restrictions on business and closing, and, you know, didn't seem to have too much of an effect. And I guess I wondered there a little bit about just kind of sort of behavioral issues. Is there sort of COVID fatigue, or, you know, what's going on that just sort of makes that curve just go slowly back up or down depending on the dependent variable? You know, the steadiness was striking in itself, I thought. And then the third and sort of final category has to do with, I guess, the magnitude of the results. I mean, you know, certainly you can see the differences on the graphs. Certainly they come out to be significant in the statistical analyses. When you look at the numbers in some of the tables, the differences, you know, seem relatively small in some sense. You know, for example, the visits in census block groups per day changes by maybe about a half for one group and close to 1 for another. So I guess it was just sort of a general comment. How do we think about sort of the magnitude of these effects? I mean, you have a large sample size, statistical significance is easy to achieve.
Right.
And you know, what can we? I think in some sense this is the value of the paper. I mean, it confirms our intuition in some sense that some groups have you know, more of an effect than others. You know, it affects some groups more than others, and this is valuable, I think, in assessing the magnitude. But how do we put that magnitude in context given things like the sample sizes and the differences that you see. So I'll stop there.
Okay, thank you very much. I'd like the two of them to decide how to respond, but it's open to both of you.
Gang, do you want to do the one on the data first?
Yeah, so let me come back to the.
You have about 2 minutes.
Yeah, so the data is from the company called SafeGraph, and I think this company just provide the free data for the mobile phone data for only Kuwait research only. So you can get the free data from the website, and it's provided data every day from the I think January 1st, 2020 to now. So this is a very good data. Actually, it includes like more than 3.6 million of point of interest across the nation, and it only contains the data for US. So you cannot get into data other than America. So
Okay, so I think we could stop there. The website is down below, so just go to the website and look around. I forgot the second question. The third one is about the significance of the results. That's a good question. I think I was impressed by the consistency across both of our measures. So even though differences are small, the fact that they're kind of consistent gives me, a little bit more confidence. It does track very well with what we kind of know on the ground, and all of these claims about how certain groups of people are disadvantaged because they're essential workers, because of all those things, it seems to really be carried out in the data. I think, the trend was the second one. I was very impressed with that as well, and it sort of said to me, after the first panic, when the government, then after the government started saying, okay, well, things are better now. When they started saying, well, things are worse now, the message wasn't received in the same way. And even though we didn't show later data, that trend, we're almost up to where we were pre-pandemic, despite having the biggest surge ever, in January.
Yeah. Thank you very much. I thought that was terrific. Good presentation and good discussion.
Thank you.
So thank you. Our next paper is by Maria Tonger and Karima Cordit and Peter Nykamp. And it's on Does Corona Impact Mobility Pattern? A Study on Sweden. So I will open it up to the three of you.
So I tried to share my screen and hopefully you guys can see the presentation. Yeah, so basically we have another co-author that is Jon Ost, who is also taking part with us. And we're basically talking about a data-driven time geographical analysis of mobility in a bit kind of the same question, but a different approach. Sorry, I muted myself instead of switching slides. So let's continue. So basically, I don't need to preach about how COVID-19 is not only a human crisis, but also socio-geographical one. The main parts that we focus about are the spatial proximity and the kind of socioeconomic segmentation. And we roughly call it white collar, blue collar in Sweden because like the racial part that is clearly traceable from United States is not traceable here. And it's not even kind of recorded by the Central Bureau of Statistics. And we focus on these changes in behavior. So this is an example of data from basically from Apple mobility trends. And we were going to look also at the thaw period, which in Sweden happened as well as in the United States. So you have basically the pre-pandemic. So we take the kind of just before everything starts to happen in Sweden, which is 16th of January. And then you can look at the peak of the first wave, which is 26th of March. And then in summer, there was a bit of kind of a thaw, and now it's in second wave. And we looked, this is from Apple, so this is by mode of transport. There is driving, walking, and public transport. And what I'll show today is only the before and during. We do not have the thaw period yet. And basically, what we were wondering about is what happens basically, right? So people avoid risks to their health, they shift to private modes of transport from mass transit, and they avoid what they perceive as dangerous areas, right? So are they more disciplined? And this is in the Swedish context. So Sweden didn't have the orders, lockdown orders, or any orders for that matter. What Sweden had is basically recommendations, please be kind of responsible and stay at home. But as you can see here, people did respond and respond pretty strongly, especially in the beginning. So what we see basically is kind of modal shift from mass transit, which is also supported by the government that say, please don't take mass transit if you can avoid it and so on. We see less traffic jams. We see also some kind of rise in what we call slow motion, walking, cycling and such for those who can do this, and thus shift in space-time mobility patterns. So if you think of this as kind of an aggregate result, right? So those who used to have a car and used the car before, now using it less because there are less things to do and because they choose to stay at home. Those who used mass transit or let's say bicycles and such, they basically either shift to a car, travel less, or shift to slow motion if they cannot stay at home. And so this is kind of our focus of the study, look at those shifts in mobility patterns and try to analyze it in this space-time perspective. So my interest is in the spatial part of that. And we look at kind of the classical Hegestrand space-time geography. And what we think about is that people, we basically think of this well-being context of that people actually need the space and for their well-being, and they have what is called activity space, and the daily activity space is impacted by this shift. So this leads to this kind of new type of spatial behavior, which is on aggregate affects the cities. So, and this is kind of the rough background of that. So we basically looked at blue collar, white collar divide. And in Sweden, according to Central Bureau of Statistics, it's about half of Swedes are blue collar workers. And of course, you have the spatial mismatch that the jobs are basically closer in central areas, but the blue collar workers, they are actually living outside of cities, which is a bit kind of different from the situation in the US, if you would think. And there are some areas which are basically more focused on public transport. And another thing that is kind of to mention, this is from another paper from some of the co-authors, that those areas that have kind of more blue-collar employees, they're also lower on social capital, which affects the well-being, as we know. And I will focus on the area of Stockholm and Uppsala. So this is Uppsala, fourth city in size in Sweden. And this is Stockholm, the main and the biggest capital city. And as you can see, the rural areas have lower kind of social capital. And we use those two data sets mainly and some more stuff. So this one on the left is basically the register in Sweden. So all the residents in Sweden are registered with their income, education, and various socioeconomics, about 10 million individuals. And the latest record we have is 2017. And the main database that we're using is mobile phone data, not GPS-based like the previous paper. So what we're using is kind of antenna-based location, which is pretty fuzzy in terms of location. So we kind of are relatively comfortable with 1 square kilometer precision of location. And in Greater Stockholm area, we have about 2.6 million out of 10 million people. And we have the phones from one company, which is not full kind of market cover, but in this area, they are pretty representative. And we also looked at first difference and diff and diff, and we took some dates before and during. So we took, for example, the during minus before, March minus January, and in diff and diff, we looked the same, but minus the year before. And we also looked at, in some cases, in differences from a year ago. For the peak area, minus the year ago. And basically what we are focusing on is our main kind of interest is the activity spaces, but we also looked at some other metrics. Yeah, okay, so let me continue. How am I with the time? Looks like I'm okay still. This is from another paper that we there is a preprint already that we use the same data. And what we can see is reduction in density of phones in the central areas of both Stockholm here and Uppsala, and reduced densities. So blue is reduced, red is increased. So reduced densities along the roads and increased densities in residential areas. And the diff and diff showed the same. So this is the first difference, this is the diff and diff. And we can also see that basically in the low areas is where all the employment is closer, right? So this is distance to 100 nearest jobs. And if we compare this to, for example, Google data on densities and on their, with our other metric, which was maximal traveled distance per mobile phone per day, then we see some correlation with what they say happens to workplace mobility and retail and recreation mobility, but not to residential mobility. So this is our background. And then we looked at different other metrics. So this metric is very similar to the number of areas visited from the previous paper. So this is before the pandemic, number of origins from which people came to various destinations. This is during. So you can see reduction in diversity of sources of people, if you will. So this is Uppsala Center, this is Stockholm Center. You can also see basically if this is diff and diff, both in terms of origin, blue is negative and red is positive. So you can see reduction in number of origins per destination and in number of destinations per origin, of course. And you also can see that it's not only from where people come and to where they go, it's also how many people travel. So this is also reduction in the size of flows. This one is diff and diff. And basically, so this is our background, right? So we were looking at, did the shift happen? How did it happen? And then we started looking at this classical Hägerstrand model. So what he called the space-time aquarium. So you have the X, Y as space and Z as time. And you have basically space-time trajectories of this is, for example, one individual coming from home, going somewhere, meeting another person and continuing back home and staying at home. So this is from Nigel Thrift's 77 paper, but based on Hägerstrand idea from 1970. So what happens during the pandemic? Or let's say this is a normal day in the life of some random couple. So one person takes a car, goes to work, have a meeting with other people, goes to a lunch meeting, comes back, has a phone call with their partner, then goes works, takes a car to pick up their partner, they have a dinner in a restaurant and come back. So if you think of a spatial projection of that, if you flatten the Z, the time, then you can have some let's say, habitat or domain, which is called the activity space. And so the red one is the partner, and that partner is taking the public transport. So as you can see, the curve is steeper because it takes longer time in this case, and their spatial pattern is like this. So this is the normal day, if you wish. If you think of a pandemic behavior, so one of the partners is shifting to work from home and another one is not. And but even though they're still at work and they have some co-worker that is also at work, others are working from home. So a lot of stuff is shifting to kind of virtual interaction, you can see on the floor the projection of their spatial pattern, the activity spaces. They're different, and we can measure that. So this was kind of our main interest. Can we actually measure that in mass on a lot of people and see what is the effect? And we basically picked up this method of using standard deviational ellipses to kind of see the measurable effects in mass on a lot of phones. Can we see this behavior that we think will happen? And I'll skip this. This is the methodological part, but basically there are different ways of measuring it. And the one we picked is the standard deviational ellipse, for the reason that it skips basically outliers, the occasional trip here or there. It kind of skips them. So it covers, in our case, 95% of mobility. If we compare it to other metrics of mobility, for example, another company that provides mobility metrics, the Descartes lab, they picked 3 different metrics, one of which is maximal distance traveled, and 2 others that kind of are about bounding geometry. And they show different, so they ended up with measuring maximal distance, but they had to deal with outliers. So what we decided to do is kind of take a measure that is relatively simple to calculate on mass and analytic, but that deals with outliers. So it's kind of our approach to that. We did look at other methods. So there are basically, this is the standard deviational ellipse. So that has been used to compare mobilities. So in this case, between 2 days in a person, this is between several persons. There are other methods such as kernel density or buffer, for example. We skipped that part for now because we decided that it's actually more practical and more useful, and it should show the effect if it's there. And what we also looked, because we are dealing with Sweden, and Sweden has very strong changes in behavior in seasons. So this is from a paper of Ole Järv et al. From Estonia, and they have kind of the same seasons, and they were using mobile phone data on activity spaces as well. And they didn't see much difference between January and March. So this is not what we would expect to see from seasonal changes. And of course, in Sweden, you would expect more activity in summer, just like in Estonia. So this is an example of one of the people that we actually know who that is, and they are volunteering to get marked, so we know who they are in the data. The rest are kind of very fuzzy locations, and yeah. So in this case, this person stayed at home. In this case, the person went to work. So what you can see is in this ellipse kind of change that you have a small and relatively round one that's a stay at home. And you can see, for example, if there is mobility between 2 destinations, it's relatively flat and larger. I'll skip, we did some comparison with other methods and such. I'm skipping that, just one comment on that. This is a trajectory of another volunteer. This is from GPS. And you have the space kind of flat and time as the Z. So this is a classical kind of visualization of what you would expect from Hegestrand model. When we use our mobile phone data, what we get is a fuzzy kind of points that are not precise. So once you look at this, you might recognize that, but if you only have this data, which is what we have for the masses, it's a bit harder to actually kind of analyze it precisely. So we have to have some kind of more fuzzy measures. So this is what we do. We take those ellipses and we compare 2 metrics that we focus on, which are kind of the roundness and the size. And this is just an example to show that like some of the values of that and the effect of roundness and size on kind of spatial behavior. So I'll just show you the results basically that we looked in mass. So this is the 2 dates. The blue is the before and the red one is during. And this is the log 10 of square root of the ellipse area. So this is like the size, the habitat of those people is covering. And you can see some reduction. So there are basically more smaller activity spaces. And also you can see that there are several groups with different behavior. And if we look at the flatness of them, then you basically see more of them there flat. So this is just the ratio of minor to major, just to have a feeling. So if the ratio is 1, that's a total kind of circle. And the larger is the ratio, or kind of the smaller, depends which one you divide. In this case, the smaller, the more flat. And the extreme case would be if you only have 2 points, then it's totally flat, right? It's approaching 0. So you have more people that basically travel between less destinations. If we look that, we also see some groups in behavior. So we see both more flat and more round. So it's actually not that simple. So we tried to kind of cluster them, and we found 4 different groups of behavior. So the small and flat ellipses are basically close destinations where a person basically goes from A to B, which are very close. There are the small and round ones, which are like staying at home or not really moving around. But those are the few cases. The more cases we have are either large and round, so that's somebody who's traveling all over the place basically, or medium and flat, which is more or less what we would expect from the original behavior. And in mass, this is basically about 1 million forms. We don't really see with the naked eye change in pattern. But if we divide them by groups, what we can see is that there are much less people with large and round ellipses. And there are much more basically that are switching to either the medium and flat or to the small and flat. And the small and round, they are kind of more inside, basically there are more of them. So this was looking at the ratio of 1,600 nearest neighbors and basically comparing them. And we see the shift in kind of percentages as well. So this is percent members, percent of people who have this kind of activity space. So the small and flat increased, the medium and flat increased, and the large and round decreased. And we also kind of looked at probabilities of switching from one to another. And how am I with time? I think I should kind of get to the conclusion on that. So just to show you a bit of kind of effects of changing. So we looked at, for example, maybe this one is kind of the most interesting, even though it's not the classical transition matrix. So if you start up as large and round, so 70% of those would stay large and round, but there are some that are shifting to medium and flat, right? So you have some changes basically, but not as strong as we expected. And basically, if we look at probabilities of becoming, say, medium and flat, if you were large and round, then these are pretty large, right? And what we also did, we mapped them in space. So these are the large and round. And what you can see is the yellow ones are more negative. They're all negative, as you can see here. But the decreases, if we look at them spatially, they happen in those 2 areas, which are kind of more blue color, if you will, in terms of the large and round. And if you look at the increases in the medium and flat, those are all positive here, except the yellow ones. So the increases in medium and flat are in those same areas, which we kind of interpret in our way as reducing number of points of interest, reducing kind of how many locations the person visits, and those who increase the medium and flat ellipses, they basically travel for work and they don't have a choice, which kind of seems to be spatially distributed the way we would expect that to happen. So this is the first difference. And we also looked at the other 2 groups, and there is kind of a significant spatial difference in the behavior, but those are less kind of in percentage of all the spatial behavior, those are less kind of prominent. And the small and round, there is basically the lowest number of areas that are like this. But what we can see is that there are some areas that really kind of reduced a lot. And in this area, there are some that increased. And we kind of think that some of those people totally switched to work from home, and some of those basically lost their jobs. So our conclusions, would be basically that people respond, first of all, they respond not only to orders, they also respond to mild restrictions and recommendations. And some people switch to work from home, which had significant impact on the total mobility patterns. And what we see more is kind of the switch from large and round to like smaller and more flat ellipses. So people avoiding redundant and unnecessary trip and reduce points along their trajectories. And this also points to kind of reduced spontaneity and in connectivity, which means less flexibility, and one might think less well-being, if you wish. And basically straighter A to B trajectories. And we started, but we didn't get there yet, which our further work is connect to the location, which means the socioeconomic of the space. We do not have a direct location, so we can direct socioeconomics of that particular phone, but what we can do is do spatial join. We kind of already done it, but didn't regress that yet. And the other thing that we want to add is at the thaw kind of period, the reopening of the businesses stage. So yeah, that was, I guess, from me.
Yeah, great. Thank you, Marina. Very nice. Bruce Newbold, you're up with regard to discussions. Thank you.
Yeah. Thanks, Kingsley, and thanks, Marina and Peter and Karima for this great paper. Really great sort of comparative piece or complementary piece to the previous paper, of course. You know, and I think like the previous paper, it showed the impact of COVID-19 on our daily mobilities and the changes, the very abrupt changes in mobility. One of the things that I really liked about this paper was the use of, you know, the classic Hagerstrand time prism models, and then, you know, teasing it apart to understand the different implications or outcomes for these, you know, what are likely different groups or the different types of travel behaviors that you can see on the ground. And so taking it from sort of the theoretical piece and then saying, here's what we see on the ground. I think that's, you know, that's a really good way to help visualize what's happening. You know, as you undoubtedly saw from the presentation here, there's a lot going on in this work. You know, and Marina went through it fairly quickly, but there's sort of different pieces, the different modeling that they did in order to take a look at it. I think in terms of my questions, some of them are very similar to the questions that Peter posed on the previous paper that I didn't fully get from the slide deck or the presentation. The you know, questions similar to Peter's around data, the access, the time period, for example. Another sort of similar piece or question was the context. And one of the things when we use big data like this, you know, we're often lacking the context for mobility behavior or any type of behavior that we're trying to get at with the big data. So what are, you know, the motivations? And I think particularly what Sweden did in terms of restricting population movements, and you made a very brief comment about that early on in the presentation, that it wasn't the severe lockdowns that we saw here in North America, but also, you know, as COVID has dragged on, how have people responded to it? Is there a sense of fatigue? You know, have they tried to return to more normality? And in fact, you know, and there's been a lot of cases where North America sort of looked over at Sweden and said, Swedes are doing it the right way in dealing with the pandemic. And I think that's a whole separate question. But there have been a lot of comparisons. Did we lock down too much relative to Sweden? But some of, you know, I sort of digress, but some of the context I think is important here. And then I think the third, and you just very briefly commented on it right at the end, is now to take a look back and do that sort of difference in difference analysis. 1 year later on, or as the economy opened up, as businesses opened up, to see how travel behaviors changed in that period. And you might see something very similar to, again, the previous paper, but it'd be interesting to sort of concretize that piece. So thank you again.
Okay. Marina, Peter, or Karima, any comments, issues you want to raise? Okay, I'll open it up to questions then for anybody. I'm very taken by this ellipse kind of rounding analysis that I haven't seen before. I mean, I've seen it in terms of other things, but I've never seen it in kind of this context, and it's very interesting. One of my concerns is, does it hide more than it tells us? And that's just an open question. In other words, it's a complex system. You're trying to put it in another complex system. And the question is, what are you trying to tease out from those that couldn't be handled in terms of direct commuting analysis? Not good or bad, just two ways of doing it. And why you would choose one over the other. Maybe I'll ask Marina about that.
Mm-hmm. So I guess that comes back to what Bruce said before about the context. So when we started thinking about that, there was a lot of discussion in Sweden. Do different socioeconomic kind of groups respond differently to those mind restrictions? And in our previous paper that I cited here, like it's the background, we didn't find significant differences. So basically, they were responding a bit slower maybe, but just a bit. It wasn't that much of a difference. So what we wanted to actually see is there like a qualitatively different behavior? So it's, of course, we all expect some kind of drop, and whatever we measure, we get the drop, right? So that's not already that much interesting anymore. So what we want to see is what qualitatively changed. And what we see in those ellipses is basically the habitat of those people changed qualitatively. They reduced their, and we were looking at that from the beginning as kind of, does that affect their well-being? Does that affect their health risks? And there is some discussion about these activity spaces. Is a bigger activity space directly means better, like more well-being or not? And it's unclear, because if you live in the urban core and you just walk to your job and everything is walkable, then you don't need a large activity space. But on the other side, if there is like a deprived area that doesn't have public transport, suddenly they're basically stuck there, right? But in between those people who used to move around and now they can't, so their change in well-being is actually pretty drastic. So that was the background of that.
Great.
So, which is why we don't take those direct metrics like total distance clocked or whatever. Yeah.
Good, thank you. I think that provides a lot of information for it.
Mm-hmm.
I think that's it. We'll call this first half of our session to a close. We will be back here at 1 o'clock in an hour. Not quite, no, I'm sorry. We'll be back here at 1 in Pacific time. That's the beginning of the next hour. So I look forward to seeing all of you then, and we'll go to the next session, which will look at great minds in regional science. So thank you very much, and I'm gonna